Some of the further mathematicians of Lungang wanted me to answer this really easy 1-mark reduction formulae question. So, IN, or Ian, is the integral of e to the power of 2x sine to the power of nx dx. Show this beautiful thing is true. Well, this, as I've highlighted here, is integration by parts. Now, when we do integration by parts, you guys know I like to say LIDI, is you leave the first term, integrate the second, differentiate the first, integrate the second. In this orientation, I don't want to leave this and integrate this because I don't know what sine to the power of nx integrates to. So in fact, I'm just going to switch them around. This is going to be the one that I leave, and I'm going to write like this, sine x to the power of n. Integrate this. Now I know you guys love substitution, and a lot of you would do substitution to integrate e to the power of 2x, which is kind of peak, but that just becomes this. So we leave, integrate, differentiate. So differentiating this, you differentiate the angle is cos, bring down the n, so it's n cos, then knock one off the power. These brackets always the same. Okay, now cleaning this up, this n and the half can come outside of the integral. So we get n over 2. We're going to have to do parts again, because what is that? I don't know what's going on. So, let's do it. So, doing our LIDI. I think I might need more space, because we're going to differentiate. Because we're going to leave this, right? Cos x, sin x to the n minus 1. We leave the first term, integrate that, which we know is this. But we have to differentiate this. We can only differentiate this using product rule. Differentiate the first term, cos differentiates to minus sine, times the second term is sin x to the power of n minus 1, plus, differentiate the second term. Well, you differentiate what's inside. I'm going to do this kind of all in one. Just listen to what I'm saying, yeah? Differentiate this is cos. Then you bring down the n minus 1. So you have n minus 1 cos of this to the power of n minus 2, because you're knocking one off the power. But then you're timesing by this cos. So it's actually cos squared. So you have, bring down the power, n minus 1, cos squared x. Then we knock one off the power, sin x to the n minus 2. Okay, that's the differential of the first term, times the second term, half e 2x dx. Okay, this simplifies. That becomes negative sine x to the power of n because you add 1 to the powers. This half can come outside. Alright, so we have a half e to the 2x cos x sin x to the n minus 1. Yeah? I'm going to expand all this in and separate the integrals. Yeah? So we have a... This is minus sin x to the power of n, like I just said. The minus half, with the minus, becomes plus half integral of sin x to the power of n times e to the power of 2x dx. Then this times this and this. This actually is a constant, right? It can actually come out with this. It becomes minus m minus 1 over 2 integral of cos squared. Actually, if I'm going to rewrite it back as this, I'm going to rewrite cos squared as 1 minus sine squared. Times sine x to the n minus 2 e to the 2x dx. We're going to have to multiply both of those terms in. This is Ian, right? Yeah, so I have a half e to the power of 2x cos x sin x to the n minus 1 plus a half of Ian minus n minus 1 over 2 integral. Multiplying these in, you're going to get e to the power of 2x, e to the power of 2x, sin x to the power of n minus 2, yeah, minus, when you multiply these, you're going to add the powers. 2 plus n minus 2 is just n. So we get e to the power of 2x, e to the power of 2x sin x power of n dx. But that's Ian again, right? And this is this, but with n minus 2. So we get a half e to the 2x cos x, sine x, n minus 1 plus a half Ian minus n minus 1 over 2. Now this, remember, is Ian, but with n minus 2. But then when you multiply with this, it becomes plus m minus 1 over 2. That is Ian. But all of this needs to go back into here. And that all equals In. Oh, man. So, we have Ian. That integral is this. Half e to the 2x sine x to the power of n minus n over 2 times all of this. Times that by minus n over 2. Minus n over 4. Times that by minus n over 2. Times that by minus n over 2. Times that by minus n over 2. Hey ho, I better not have made a mistake here. I'm timesing through now by 4, right? If I times everything by 4, that was a half, right? Yeah. Times everything by 4. Times everything by 4. Times everything by 4. Times everything by 4. This is calm. This is what it is. In fact, that's probably going to give me something like this. I'll double check in a second. It's bringing all these Ians. Now the look, that matches up. Calm. What's the time? Oh God. I got somewhere to be, bro. So what was I doing? That. Okay, this I think I'm going to deal with first. 4in. Here I can factorize out e to the 2x. What did I want to factorize? Yeah, you always factorize out the smallest power, right? Because when you take out e to the 2x, you're left with 2. Then you subtract the powers. N minus 1 is just 1, so you get sine x. Minus, you took that out, so n cos x. Yes. Then you have minus n in plus n, this I'm not changing, right? Minus n squared in plus n, which cancels. And then this, we're going to bring here, because then we have n squared in with this. Then when you factorize it, you get this. How much below can I write at the moment? I don't know. Hopefully you guys can see it. So this is going to come with this. Then you're going to factorize out in, and you get n squared plus 4 in is that plus 2 sine x minus n cos x times sine, how did I write? E to the 2x sine x to the power of n minus 1. And that's proved. Yeah! Come on, let's go.